All right, today we're going to dive into something pretty wild. It's a radical new idea that really challenges how we think about, well, everything. Time, memory, you name it. It proposes that our past isn't really gone, it's just echoing all around us. So let's get into how that could even be possible. We all have this built-in metaphor of time as a river, right? It just flows in one direction, from the past through this moment and off into the future. But what if that's completely wrong? What if time isn't some force that's pushing us along a straight line?
So the very first step in wrapping our heads around this new theory is to just take that whole river idea and throw it out. We've got to replace it with something a lot more dynamic and, frankly, a lot stranger.
Okay, so on the left, there's our old friend, the river, time as a straight line. But on the right is the new proposal, time as a resonant field. A better way to picture it is to think about the surface of a pond. It's not a straight line, it's this incredibly complex, shimmering interference pattern that's created after you toss a handful of pebbles into it.
So what does a resonant field actually mean? Well, in this model, time isn't fundamental. It's not a thing on its own. Instead, it emerges from the way countless tiny cycles and oscillations all interact with each other. When these little cycles sync up, you get order. When they fall out of sync, you get chaos. And time, well, time is the beautiful, messy, constantly changing interference pattern they create together.
Okay, so if we accept for a second that time isn't a river, what on earth does that do to our idea of memory? Well, it means memory isn't what we thought it was either. It's not about storing things, it's about mirroring them.
We tend to think of our brains like a computer hard drive or a big filing cabinet, right? We think memories are stored away like little files that we can pull up and look at. This new model says, nope, that's not it at all. Memory is an act of reconstruction. The brain doesn't just play back a recording, it actually triggers a resonance that makes the original pattern of an event happen all over again, like an echo of the past showing up in the present. Now, the fancy physics term for this is phase conjugate mirroring. I know, it's a mouthful, but the idea behind it is actually super cool. In optics, there are these special mirrors that can take a totally scattered beam of light and reflect it in such a way that it travels backwards and perfectly reforms its original shape. This theory is saying our memory might work just like that. An event creates a unique pattern, and remembering is the act of mirroring that pattern, causing it to pop back into existence in our minds.
Now, I know what you're probably thinking. A resonant field? Mirroring memories? This all sounds really abstract, almost poetic. For any of this to be real, there would have to be some kind of physical structure in the universe that can actually do this stuff. And, amazingly, scientists think they've found one.
And that's the million-dollar question, isn't it? If time and memory are based on these incredibly complex patterns that are sort of self-similar but never exactly repeat, what kind of material could possibly hold a code like that? Well, the answer comes from a very, very strange form of matter.
Meet the quasi-crystal. It is one of the weirdest and most wonderful things in physics. It's a structure that is perfectly ordered, just like a normal crystal, but with one mind-bending difference. Its atomic pattern never, ever repeats. It just goes on forever in an orderly but non-repeating way. It's a perfect physical blueprint for something that's organized but never identical, just like this new model of time. And this is exactly why the quasi-crystal is such a compelling piece of the puzzle. It has that aperiodic order without repetition. It contains patterns within patterns, encoding relationships across all different scales. This makes it the ideal candidate for a physical material that could actually encode time, not as a simple line, but as this rich, complex, multi-dimensional pattern. And scientists even have a specific structure in their sights. It's a type of quasi-crystalline structure called the Kagome lattice. If you look at it, it's this really elegant geometric pattern made of triangles that all share corners. It looks simple, but that specific arrangement gives it some incredibly complex physical properties that could make it the perfect stage for these temporal echoes to play out. So we have the theory, and we have a potential physical structure. The next logical question is, how does it actually work? How does something like a Kagome lattice actually create one of these memory echoes that we've been talking about? Well, it seems to break down into a four-step process. First, an event, let's say a sound you hear, injects a specific pattern of energy into this lattice. Step 2, special properties of this lattice, something physicists call flat bands, essentially trap the information of that pattern, holding on to its phase relationships. Then, step 3. A new stimulus, some external jolt, causes the whole system to start vibrating or resonating. And finally, step 4. The lattice responds by spitting out a perfect copy of that original pattern. It produces an echo of the initial event, and that is the memory.
So this is the really cool part, where it all snaps together. We can now map those big, poetic ideas from the beginning directly onto hard physics. That idea of irregular, recursive time, that's the geometry of the Kagome lattice. Memory as mirroring, that's exactly what those flat band phase templates are doing. And the echoes of time, that's a direct result of measurable temporal interference in the system. It's not just a metaphor anymore.
Okay, this all leads us to one of the biggest, most profound mysteries in all of physics. If time isn't a river, if it's this field of echoes, then why do we only experience it moving in one direction? Why can we remember the past, but we can't remember the future?
This quote really just wraps up the whole theory so perfectly. Time isn't a flow, it's a pattern of relationships, a standing wave. And memory isn't playback, it's an echo, a reconstitution of resonance, happening in this physical quasi-crystalline structure.
And here it is, the really mind-bending answer to why time seems to move forward. The traditional explanation is entropy, that things tend toward disorder. This theory offers a completely different answer. It says the arrow of time comes from the quality of the echo. See, a theoretically perfect, flawless echo would be indistinguishable from the original event. That would be like time running backward. But in the real world, reflections are never perfect. There are always tiny flaws, tiny asymmetries. And it's those imperfections in the mirrored echoes that give time its direction. The arrow of time is the signature of an imperfect memory.
It's a profound shift in how we see things. The past isn't gone. Its pattern is encoded into the very fabric of reality, just waiting for the right vibration to resonate again. And that leaves us with one final, fascinating question to ponder. If our own consciousness is able to listen to these echoes and form what we call memories, what else out there might be listening too?